Hi, today I want to talk about the cube root of unity in complex numbers for advanced level. Now, if you have, let's say, z cube minus 1 is equal to 0, let's say plus 1 is equal to 0. So how can I find all the roots of z cube plus 1 is equal to 0? First thing we do is we say that z to the cube is equal to negative 1, meaning that z is equal to the cube root of negative 1. Turns out that the first root is going to be equal to negative 1, so here we are, that's the answer. What about the other two roots of the complex number? So, if we take, let's say for example here, z is equal to minus 1, so I can say z plus 1, multiplied by some quadratic expression, z squared plus kz plus 1 is equal to 0. Now from here, it's clear that z times z is z cubed, z times kz is plus kz square, z times 1 is plus z. 1 times z square is z square. I've got 1 times kz is plus kz. I've got 1 times 1 is plus 1. All of that should be equal to 0. Now over here I've got z cubed. Rearranging that is k into z square, can you say z square times k plus 1. How is that? Because k times z square, 1 times z square, 1 and then k, plus I get z and z. Z can be factored out, and I've got inside 1 plus k. And then plus the 1 is equal to 0. So now where do we go from here? From this root, the coefficient of z square, is equal to 0. So coefficient of z square is equal to 0. That means k plus 1 is the coefficient of z square here. So k plus 1 is equal to 0, meaning that k is going to be equal to negative 1. So now that we've got k is equal to negative 1, I can put k over here. So I've got then z plus 1 into z square minus kz, alright, plus 1 is equal, what am I saying? It's not minus z, because k is minus 1, so minus z. We want to solve this, so how are we going to do this? So z square minus z plus 1 is equal to 0, meaning that if you put this in the form of completing the squares, so we've got z minus 1 over 2, alright, to the square, and this can go on the other side, okay, plus, I'm going to say minus half to the square, plus the 1 is equal to 0. So now from here, I've got z minus half, all squared, here's 1/4, plus 1 is equal to 0. Further, z minus 1 over 2 to the square is equal to 1 minus 1/4 is 3/4. The 3/4 can go on the other side, becomes minus 3 over 2. So now I've got z minus half is equal to the square root of minus 3 over 2, which is then, okay, so square root of minus 3 over 4. Because 1 minus 1 is 3/4, yeah. So square root of minus 3 to the square. So the square root of 2 is going to be equal to 2. And I've got a minus here. So if you get a minus, basically we're looking at square root of negative 3. What is the square root of negative 3? It is square root of 3 and then I. Okay? So square root of 3 and then I. That's a complex number. And the square can become plus or minus, got two roots, okay? So then the first value of z is going to be equal to, the second value, because the first value was minus 1. So then from here I've got half plus a root of 3 over 2i, let me call this one z2, and I've got z3, if you want, is equal to 1 over 2 minus root of 3 over 2 I, of course. So these are the two roots plus this one. Now, of course, this is for advanced level. Here, you can see on the corner, it was solved by a different method using Euler's, De Moivre theorem. This is more for further maths, and this one is just for A-level maths. I hope that helps for cube root of unity. Take care.